In this lesson, we're going to be learning how to solve equations with variables on both sides of the equal sign. We're also going to take a look at a couple examples that we call identities or no solution. Our first example, 7k plus 2 equals 4k minus 10, can be simplified by moving all constants to one side of the equal sign and all coefficients to the other side of the equal sign. And we're going to follow the same process that we've done for our multi-steps. We're going to draw a fence down our equal sign. And it really doesn't matter which side we place the variables on, or the terms with the coefficients. In this case, I'm going to go ahead and put the variables on the left-hand side of the fence. Since I have a positive 4k, I'm going to undo that by subtracting 4k. And what I do onto one side, I do onto the other. And so now I have 3k plus 2 is equal to minus, bring this minus sign down, minus 10. Alright, so we're moving a little bit closer. We have all of our variables on one side of the fence. And so now we're going to get rid of the plus 2. We're going to move that to the right side of the fence. Since it's plus 2, we're going to undo that by subtracting 2. And what I do onto one side, I must do onto the other. And so I have a positive 2 minus a 2. Those cancel each other out. And we're left with the 3k on the left-hand side of the fence is equal to a negative 10 minus 2 is a negative 12. I now have a one step, and our one step says that we should undo multiplication by division. We're going to divide by 3, and the negative 12 divided by 3, it leaves us with k equals negative 4. Now what we should always do is check our solution. So we'll go back to the original equation and plug in our solution of negative 4. Does 7 times negative 4 plus 2, does that equal 4 times negative 4 minus 10? 7 times negative 4 is a negative 28 plus 2. Does that equal 4 times negative 4, which is a negative 16 minus 10? Does negative 26 equal negative 26? Yes, it does. And so our solution of negative 4 is correct. Our next example involves grouping symbols. So we're going to use the distributive property on both sides of the equal sign. 7 times 4 is 28. Bring down our subtraction sign. 7 times a is 7a. And that's equal to 3 times a, or 3a. Bring down our subtraction sign. 3 times 4 is 12. So now we can go ahead and draw our fence. And what we do onto one side, we're going to do onto the other. I'm going to move all my variables to one side of the fence and all my constants to the other. I'm going to go ahead, because this has a negative sign or a minus sign in front of the coefficient 7, I'm going to do the opposite, which is to add 7a to both sides. And what I do onto one side, I do onto the other. A minus 7a plus a 7a lets us get rid of the coefficients on this side of the fence, leaving us with a 28. 3a's plus 7a's is 10a's. And then we have to bring down our subtraction sign and the 12. So now let's go ahead and move our constants to the other side of the fence. And that means we will add a 12 to both sides of the equation. And so I get 40 is equal to 10a. I now have a one step. I'm going to go ahead and divide by 10 on both sides of the equation. And I'm left with 4 is equal to a. I'm going to go ahead and check my work by plugging a 4 in to my original equation. Does 7 equal 4 minus 4, or times 4 minus 4, does that equal 3 times 4 minus 4? Does 7 times 0 equal 3 times 0? Yes. 0 equals 0, and so our solution of 4 is correct. When we're solving equations, multi-step or equations with variables on both sides of the equal sign, sometimes those equations will give us statements that are always true. This is called an identity. Identities have infinite solutions, and that means no matter what value you put in for x, it will always make a true statement. Let's take a look at a sample. We have an equation here where we have to use the distributive property on the left-hand side of the equation. So 3 times 4x is 12x. 3 times 2 is 6, and we'll bring down our subtraction sign, is equal to negative 6 plus 12x. And so if we go ahead and draw our fence, and we move all of our coefficients to one side of the equation and all of our constants to the other, we'll begin balancing our equation. Let's go ahead and undo the subtraction of the 6 plus 6, and we'll do that to both sides of the equal sign. Minus 6 plus 6 equals 0, so that leaves us with a 12x on the left-hand side of the fence. And if we subtract negative 6 plus 6, that also is 0, leaving us with 12x on the right-hand side of the fence. So if I divide both sides by 12, I'm left with x is equal to x, which is always true. Sometimes we come upon equations that can never be true, and this means that our answer is no solution. A sample of that comes with this equation. 2x plus 7 is equal to negative 1 times the quantity 3 minus 2x. If we go ahead and distribute on the right-hand side of the equation, we're left with the 2x plus 7 is equal to a negative 3 plus 2x. So I'm going to go ahead and subtract 2x from both sides of the equation, and I'm left with 7 is equal to negative 3, which can never be true. 7 can never be equal to negative 3, and so that ends up as a no solution.